What's up, guys? Let's start. Today's class, we shall be solving this, starting with the chapter called Gravitation. Now, what is important, what's not important, everything is going to be discussed. Are we done with organic chemistry? No, the last part is left. But I thought of doing this chapter because this is one chapter which is like the okay. To break it up, your first PUC will have two textbooks. First one with which has like seven chapters. The second one is going to have the next seven chapters, so totally 14. In the second textbook, this is the first chapter and it's called as gravitation. The problem here is people complicate this chapter a lot. To be honest, it's a very simple chapter. Approximately, I'll take 2 classes to finish it off, including numericals. Now, usually what happens, numericals were being asked almost all the years, but last year there was a change in pattern in the question paper. Numerical was not asked. Now, how to solve, what else will be asked apart from numericals, I'll tell you right now. Obviously, at this point of time, you won't understand the meaning of anything, but just stay with me here. There's something called as Kepler's law. Kepler, okay? Kepler's law will be asked 100% of the times. Now, the only question is, where will it be asked? Will it be asked as a 2-marker or a 3-marker? That's a big question mark. But end of the day, for sure, it will be asked. Now, how will it be asked? First type of question is, they'll be like, define Kepler's law and give us, define, okay, there are 3 laws basically. All 3 laws are supposed to define and you'll be getting 3 marks. Or they'll be like, name them. Depends. If naming is there 100% or obviously won't be such a huge concept, but defining, it takes time. Now, am I a big fan of this kind of question? The answer is a no, because it's more of a theory. What else kind of questions will be asked? Please remember, this chapter called as gravitation is completely derivations. Completely. Fine. In fact, Kepler's law is the only part where theory is involved. Other parts are 100% derivation based. So you'll see in today's class, I'll be solving few derivations. So to break it down, definition from this Kepler's law, derivations and numericals. Numericals, I'll tell you guys 3 numericals. Out of 3, 100%, if by chance a numerical is being asked in a college exams, out of these 3 only will be asked. Nothing apart from this. Fine. We will solve all the things, but end of the day, these 3 are very important. What 3? I'll tell you. Now, first derivation. Now, if you ask me, sir, without concepts, can we do derivations? That's the whole chapter. There are no concepts, only derivation. Fine. First thing is, I think the reason they're trying to give the reason they're trying to give more importance to derivations rather than concept is because there's nothing new in this chapter. Gravitation, everybody knows, is lowercase g and caps g. G means acceleration due to gravity. Caps g means it's a gravitational constant. This is exactly what is there, because all these things have been learned in previous classes. They're only trying to focus more on derivations. The first thing, they'll be like, derive the relationship between g and caps g. Crazy famous question for a 3-marker, can also be as for a 5-marker, but as far as I know, they'll ask you only for a 3-marker. Now, how to start off with this? Understand, everybody knows what g means, lowercase g. It means acceleration due to gravity. Caps g means gravitational constant. Now, where is caps g being used? Not everybody knows. We'll discuss about that and then we'll try to start off. Let's say, let's understand any type of logic. Okay, let's say you're a person standing there, or this can also be applied for planetary bodies or outside Earth, inside Earth. All these things are fine. So I'll place a point X here. I'll place a point Y here. So both of them are trying to get, will obviously be pulled towards the Earth because of the concept called as gravity. When they're getting pulled, they'll be pulled with some kind of force. Fine. This force is called as, will be represented by F. Okay. Now the only formula which uses cap G is nothing but F is equal to G m1 m2 whole thing divided by r square, where g is known as the gravitational constant, m1 is nothing but mass of one object, m2 is the mass of another object, and r square is the distance between them. Okay, planetary bodies also you guys can take. Now, this is one way of representing. The same thing what people do here is, they'll be like F is equal to G, instead of writing m1 m2, they'll write caps m and lowercase m whole thing divided by r square. There is absolutely zero differences between both of them. Now, why are they trying to choose the second form compared to the first form? Both are mass only, but it is going to be easier for me to cancel. See, when I'm trying to use numericals, no, I'll be trying to use the first form, because end of the day, I realize what m1 and m2 is. But when I'm trying to derive something, always try to use the second part. It's easier for us to cancel. Now, so how do I start off? You'll be like, force is given by F is equal to G m by r square. This is my equation number 1. You'll continue. You'll be like, we also know one more formula. What is the other formula of Newton's second law of motion. I hope you guys remember Newton's second law of motion. F is equal to ma. This is what we guys know. Fine. But right now, just imagine whenever gravity has been involved, the A becomes G. So it makes more sense if I write F is equal to mg. I'll be using this. So you'll write according to Newton's second law. Second law, we know that F is equal to m into g. If you write m into it, the answer is wrong. I'm telling you right now, because the main question says what is the relation between lowercase g as well as caps G. Fine. Now, here m into g I write. One second. I'll mark this to be equation number 2. Fine. Now, if you focus on both the equations, now see this in college, okay, they do some bullshit and all. They'll write 4 pi 3. All those things are not at all required. I'll teach you a very simple way. Listen, we know that both the left hand sides are same. Okay, which means I will be able to equate the right hand side. So equating equation 1 and equation 2. Now, in equation 1, what is the right hand side? G m, one second, G m uppercase M by R square is equal to M into G after equating. Now look at this. Didn't I tell you one hint? When you're trying to solve derivations, always try to use the right hand side. This one, because it'll be easier when we're trying to cancel things. Focus here. M and M gets cancelled. Fine. M and M got cancelled. Now, what and all is remaining? G is remaining as it is. Left hand side, caps G, caps M, whole thing divided by R square. Now, if you ask me what is the radius mean here? Radius always means radius of the earth. So I'll write RE. Okay. M means what? ME, mass of the earth. G, you need not write GE because it's understood. Fine. So this is the answer. So if they ask you what is the relation between lowercase g and uppercase c, so it will be like G is equal to GM by R square. Or very, very, very useful for your numericals also. Instead of trying to use all these kinds of steps, we can use the answer directly, and we can use the formula directly and get the answer. I'll repeat it. Initially, we apply, this is the force between two planetary bodies. Example, so given by F is equal to Gm, lowercase m, uppercase m, whole thing divided by R square. Okay, then I also know Newton's second law of motion. F is equal to mg. You don't write A. I told you why. Since the left hand side is the same, we equate the right hand sides. We cancel whatever is required. So G is equal to Gm by R square. What is the actual meaning of M and R? It is nothing but mass of the earth as well as the radius of the earth. This is one derivation. First derivation done, usually a 3 marker. Okay. Next derivation. They'll ask you, what is the variation of G? Again, understand lowercase g with height. So they'll be like, what happens to the value of G, acceleration due to gravity, as we have some height there? Fine. Now, obviously, I'm talking about gravity, which means Earth's surface has to be drawn. So generally draw Earth's surface. Fine. Earth is going to have some radius. Mark that radius to be RE. The reason I'm using caps R is because Earth's radius is actually huge. Fine. That's one point. Now see, I'll tell you. They're telling what is the variation of G with respect to height? No, place some object outside the Earth's surface in such a way that it is h distance from the Earth's surface. So this is m. So compare m and the Earth. M is some kind of mass outside the Earth. Fine. The distance between m and Earth is nothing but h. H meaning what? Height. Don't get confused. In this case, height and depth don't mean the same thing. Depth always in this case means the Earth's crust. This is the Earth's height. Okay. So myself, how can Earth have some height? What bullshit? This is the Earth's radius. Okay. So outside the Earth's radius, you're trying to place some point, and that point is at the distance h from the Earth. That's the whole point. This diagram is important. Now focus. How do you start off? Very simple. You're going to start off. The reason I started off the chapter with this derivation is because you will see this formula being useful throughout the numerical as well as the derivation. Just now I told you, I'll apply it right now. So we know that G is equal to Gm by R square. I'll go a little deeper. I'll write G as it is, M-E-R-E. Okay, mass of the Earth as well as the radius of the Earth. Now think for a second. R and H, according to me, both are same only. I'll tell you why. Because R is nothing but, let's say, 10 centimeters. Height can also be 10 centimeters. What I'm trying to tell you is, both of them are nothing but some kind of distances. Both of them. Again, this might be meters. This also might be meters. End of the day, both are still distances. Remember this. Okay. Now, I will go back. I'll apply this logic. This was when, equation 1, when the mass was not present, or in other language, just imagine this m being present on the Earth's surface, somewhere here. Okay. If it was case number 1, this is case number 2. If it is case number 1, then the formula is GME by RE square. Why? Because only the Earth's radius is being brought into picture. But the moment it goes to 2, some extra distance was there. I'm not supposed to ignore that. So what I'll do, when m is placed at height h, okay, at h, then it becomes, left hand side becomes GH. Equation 1 is remains as it is. This is at the surface, of Earth. Okay, we got the answer. Left hand side becomes GH is equal to, careful, the numerator remains the same, g as it is, because the mass of the Earth remains the same, but the distance increases. How? It was r square, now it becomes, careful guys, re as it is, plus h. What was the distance when it was on the surface? Only re. What is the distance now of m? Re plus h. Complete thing, because both of them are distances. The whole square was there. I copy paste the whole square as it is. This is equation number 2. That's all. Fine. Height always means you will add. Just imagine one person is sitting on your shoulders. Will your total height increase or decrease? It will increase. Now, will both of our heights changes? No. For example, you had some height, let's say 6 feet. So I'll write initially the height was 6 feet. Later, once the person comes and sits on your shoulder, let's say that person is 5 feet. So it becomes 6 plus 5. Okay, 6 plus 5. You're trying to add up. Same concept here. One person was sitting, one person was placed exactly on the surface of the Earth. So only RE was being affected. But the moment it goes into space, some extra distance also has been covered. I cannot ignore that. So it's like when you place a person on your shoulder, can you ignore them in terms of height? No, they will not be ignored. Okay, now focus. So in both the cases, I wrote the answer, but the only thing is I changed the left-hand side as G as well as GH. Now you have two equations. Always remember, divide one by the other. Divide equation 2 by equation 1. Okay, so we know equation 2 is GH. Guys, I'm not trying to tell both are same. Both are not the same. You guys, I mean, you being alone and you trying to carry a person, is both the things same? No. So it becomes GH by H. I mean, GH by G. The reason I spoke about the same thing is because here both were the same. Both were some kind of forces. Okay, but in the current derivation, both are G itself, but at a different distance. It matters. Okay, so GH is by H is equal to, what is the value of GH we got right now? GME by RE plus H. GME whole thing divided by RE plus H the whole square. Your teachers will tell always write E in terms of caps. That's one bullshit logic I felt. Okay, there's no need for that. Whole thing divided by, what's the value of GME by R square? Okay, cool. GME by R square. I can actually cancel right now, or I'll simplify it for you. Left hand side, don't change anything. GH as it is, divided by G also as it is. Right hand side, denominator always becomes the numerator. So it becomes GME whole thing divided by RE plus H the whole square into, flip it. It becomes RE the whole square whole thing divided by GME. Okay. Now focus, G and G gets cancelled, ME and ME gets cancelled. After getting cancelled, on the left-hand side, absolutely zero changes. So it becomes, it remains as GH by G is equal to, on the right-hand side, see, focus properly, only the R parts are remaining, the distance parts are remaining. So can I write it as RE whole thing divided by RE plus H the whole square. Okay, I'm trying to simplify it, therefore I put the whole square. Now maximum, what can be done? Think for a second. It is better if a bigger term is there on the numerator, correct? For example, a plus b whole thing divided by c can be written as a by c plus b by c. But if it is c by a plus b, it is going to get kind of difficult. But actually, if you see, the letters used almost are the same. It's just that the placement is different, correct? So how do we turn c by a plus b in terms of a plus b by c? We flip it. Correct. We flip it. Remember this. I'll tell you why I'm talking about this concept here. I'll go back right now. Before flipping it, what I'll do, okay, fine. I'll keep the GH by G as it is equal to, I told you that a bigger thing in the numerator was not helpful for me. So therefore, I want the same thing on my numerator. I flip it. Once I flip it, it becomes RE plus H whole thing divided by RE. Correct? There has to be some kind of change, no? I didn't even change the left-hand side. Keep that as a, that's an important rule. Do not change the left-hand side. Keep it as it is. So only the right hand changed, but I'm supposed to show them some difference. What's the difference? This plus 2, which is there as the power, after flipping becomes minus 2. Very important. Till this step, it was plus 2. The reason it became minus 2 is because we were not comfortable with the bigger part being on the denominator. Therefore, we tried to shift it, flip it. Now, once we flip it, it became minus 2. Now, what I'm going to do, keep the GH on the left-hand side as it is. Shift the G to the other side. G, observe inside the bracket properly. Just now I explained. A plus B by C is nothing but A by C plus B by C. Now divide it. Now the denominator RE belongs to both the parts. So it becomes RE by RE plus H by RE whole to the power minus 2. I just flipped it and divided them. Now what can I observe? I can observe that RE and RE are same. Will get cancelled. Cool. So in the next step, what I'll do, one second, this is fine. In the next step, what I'll do, I'll keep the GH on the left-hand side as it is, LHS. Right-hand side, G remains as it is. After getting cancelled, 1 remained. 1 plus H by RE to the power minus 2. People stop here. You should not. Please remember one thing. There's one concept here. If you see, the radius of the Earth here, okay, in the diagram here is approximately 6,400 kilometers. Okay, 6,400 kilometers. Now the height, example, let's say is 100 meters. Do you think this 100 meters will make a huge difference when it comes to this total distance? 100% no. 100% no. But will it make some difference? Yes. Will it make a huge difference? No. So since we write this, since RE is too big compared to H, we can ignore a few things. Okay. Now, what to ignore or what can be done, I'll tell you. So you'll write that since RE is huge compared to the height, what we can do here is we can bring the power inside. Okay. This condition helps me to bring the power inside. One, again, the power as a minus. The left-hand side GH remains is equal to G remains. 1 also remains. Now, the power will come and support the depressed ones. In RE and H, who was lower in number? H was lower in number. So, minus 2 will come and assist the depressed one. So, the plus into minus 2 becomes minus 2. H as it is, whole thing divided by RE. This is my final answer. This is what we'll be using for your numericals also, which means you should not stop here. You should always stop here when it comes to the answer. Okay, I'll repeat the whole thing again. Regular, it was mass placed at position 1 and position 2. Mass at the Earth's surface is given by the formula. Sorry, when M is placed at the Earth's surface, it's given by the formula G is equal to ME by R square. How do we know this? From the previous derivation. Done. Now I'm telling to the same Earth's surface, add some height. If you add some height or just place the mass at some distance above the Earth's surface. So H comes into picture, but H is also some kind of distance. So therefore, I add RE plus H the whole square. Now I realized G and GH are not the same, but since I have two equations, I'll divide one by the other. GH by G I do, I copy paste. Then I realized denominator becomes the numerator. Flip it, gets cancelled. For my surprise, left-hand side did not change. Right-hand side, RE by R plus H, whole thing divided to, whole thing raised to the power 2 was there. But you realize that a bigger thing in the denominator is not useful. I'm supposed to flip it. You kept the left-hand side as it is. Right-hand side, you flipped it. So since you flipped it, there has to be some kind of change. That change is nothing but the plus 2 becoming minus 2. It becomes minus 2. Fine. Now, the main reason why we changed it is because we wanted to distribute the RE throughout. I'll do it. But before that, I also shift the G to the right-hand side. It becomes GH is equal to G into one bracket. So RE gets divided into both the parts. RE by RE plus H by RE. It gets cancelled. The answer becomes 1. 1 plus H by RE, whole thing to the power minus 2. Done. Now, I told you RE is way too much compared to H. So, the power comes in. This condition helps me. Okay, if you ask me how the answer is based on binomial theorem. Okay, the power can come inside the bracket. Now, once the power is coming inside the bracket, the plus into becomes minus 2. Minus 2 H, the plus into minus. Again, the power will come and always assist the person who is always depressed. In this case, H is depressed. Depressed meaning low in number. Fine. So it becomes minus 2H by RE. This is my final answer. That's it. Don't get confused. This is variation of G with respect to height. A similar concept is there, which is called as variation of G with depth. Both are not the same, guys. Depth is you're going towards the Earth's crust. Now, how do we start off? I'll draw a reference diagram. Let's imagine this to be the, sorry. This to be the Earth's surface. Oh, my bad. Okay. Now what's going to happen? There's RE. Depth meaning, just imagine take a drilling machine and keep going towards the earth crust. So after some point of time, this will become the so basically this is the depth. Okay, this is the depth. Height was outside. Depth is inside the earth surface. So you become two circles. So outer circle is the earth surface, earth. Inner circle is the earth surface after going through it. Now, how do we start off this? Now, what's the main difference? When it comes to height, height was outside. So therefore we added RE plus H. Here depth is inside. Therefore we subtract. Okay, that's the only difference. Depth meaning we subtract, height meaning we add. That's all. Now, how do we start off? Very simple. We start off with the same thing. G is equal to GME by RE square. The starting of both the things are the same, RE square. Now, one small change has to be kept in mind here. Fine. Forgot about changing all these things right now. I'll give you a direct answer anyways. The reason is because we are trying to talk about a sphere here. Okay, sphere. Earth is a sphere, which means once you start going through the Earth's surface, the volume of the sphere is being affected. Remember this, the word volume comes into picture when it comes to depth. Volume and depth are interrelated. The volume gets affected. Okay, fine. Now, if you look at this, there is no V. If you look at the formula G, there is no V only here. From where to get volume? So what do we do here is we use somewhat our old strategies, some sixth standard stuff, where we learned something called as density. We learned that density is equal to mass by volume. Everybody knows. Now, the good thing here is we know mass. If we know mass, I'll keep the mass there itself. I'll multiply both of them. Can I write density as rho, short form? Volume becomes V. So in the next step, what I'll do, I'll write G as it is, lowercase, uppercase G also as it is. Instead of writing ME, I'll write rho, which is nothing but density, into volume, whole thing divided by RE square. Okay? Now focus. I wrote the volume came into picture. Volume of the what? Earth is a sphere. Volume of the sphere is given by, again, old strategies. Keep the G there itself. Rho also there itself. RE square also as it is. Volume of a sphere is given by V is equal to 4 by 3 pi R cube. This is the formula. Now, in the next step, instead of me writing V, I'll write 4 by 3 pi RE cube. Why RE? Earth? No, that's why. I'll explain the step again. From here to here, the reason I did this is because I realize Earth is a sphere. Wherever there's a change in depth, there's always a change in volume. I realized that Earth is a sphere, which means volume of a sphere has to come into picture. But the problem was in the thing, we had no volume. So how do we get volume? Old strategies. We use density equals mass into volume. I crisscross. I realize that mass is equal density into volume. Instead of writing ME, I write rho into V. In the next step, I write the G as it is, rho also as it is. Thankfully, I know the formula for volume of a sphere given by 4 by 3 pi r cube. I just write it here. Now I'll see what can get cancelled. According to me, I can see that RE square and RE has a lot of potential to get cancelled. Okay, let's cancel that. After cancelling, what and all remains, I'll add in the next slide. So left-hand side G remains, right-hand side G remains, rho remains, 4 by 3 remains, 4 by 3 remains, pi remains. After cancelling, only RE remains. Only RE remains. This is what is remaining. Now focus. 4 by 3 pi RE, this is what remains. What can be done? Can I cancel something at this point of time? At this point of time, nothing else can be cancelled. Okay. I'll just keep it as it is. Fine. This becomes my equation number 1. Fine. Now, don't get confused. Height was much more simpler, I realize, but depth is also important. Can't help. Now, think for a second. This was at the surface. Now, if I go deeper to the, deeper in the earth, towards the Earth's crust, it will become at depth D. What is going to happen? Should we focus on such huge steps again? No, not required. Look at equation 1. Almost rewrite it. G is equal to G, rho, 4 by 3 as it is, pi as it is. Now think for a second. Height means the complete thing increased. Depth meaning the radius will decrease. So write RE minus D in brackets. I hope you guys realized it. So until you get the first equation only is difficult. Once you get the first equation, getting the second equation is just one step. What do? We copy the first equation. Wherever there is RE, we convert that in terms of RE minus D, name it as equation number 2. That's all. But what I forgot here is left-hand side at depth D becomes GD. Just like it became GH, it becomes GD. Now you have two equations. Just like the one which we did in the previous, for the previous one, we divide one by the other. Dividing divide equation 2 by equation 1. Always 2 by 1. GH or GD should always be on top. So left hand side becomes GD divided by R is key. GD divided by G is equal to, in the second equation, what and all is there? G rho 4 by 3, everything I copy. Careful. G rho 4 by 3 pi RE minus D was there. Here, G rho 4 by 3 pi RE was there. Copy that also. Now, if you see, actually, it feels very simple, no, at this point of time, because everything is going to get cancelled. Okay. Left hand side, GD by G remains. RE minus D whole thing divided by RE. Okay. I forgot to put bracket. Now, what can be done? Before doing anything, what I'll do, I'll keep the GD there itself, G also there itself. Don't you think in the previous height part, we had to flip it because the denominator was not matching, because we wanted a simpler denominator. This was more complicated, we wanted a simpler denominator. But here, don't you think we already have a simpler denominator? It's only RE. What I'm going to do, I'll distribute that RE throughout. So it becomes RE by RE minus D by RE. Okay, gets cancelled. It becomes 1. Now crisscross G, this one. So keep the G, D there itself. Crisscross, RE gets cancelled. 1 minus D by RE. This is your final answer. So for both height and depth, the answer has a minus only. The answer. But when you're going to start off, height will add and depth will subtract. But for the answer, both will have minus. How to remember? If it, I'll write the GH right now here. GH is equal to G, everything as it is. 1 minus by RE also as it is. If it is depth, you'll only write D. If it is height, you'll write 2H. That's the only thing, because people get a lot confused when you're trying to solve this. You should not. Fine? You should not. Remember this. Both of them, 100% one will be asked. 100% one will be asked. I'm not even, there's no doubt here. 100% it will be asked. Fine. So till now, we solved 3 derivations. Please practice all these 3. Very important. In tomorrow's class, we will solve 3 more. See, I can finish off all the 3 things in one class. Fine. It'll go over the head. Fine. But understand, out of these 3, 100% 2 will be asked. I'll tell you how. This one will for sure be asked for 3 marker. This G, this one, first one. For sure. Out of height or depth, 1 will be asked. I'll tell you how it works. If a derivation is based on height, a numerical will be asked on depth, and vice versa. Fine. So make sure you guys practice each and everything twice. Tomorrow's class, we'll finish off this chapter. Okay. In fact, I'll send you one PDF for numericals also. You check that, but don't solve it, because I will be solving it. It's just that to give an idea as to how simple it is. Okay. I'll send that also. So see you in tomorrow's class. Please practice this twice. So totally 3 into 2, 6 you'll practice. Okay. 3 derivations twice.